Scientific studies regularly announce new dangers in our environment. A symbol of permanent, unlimited communication, cellular phones are now thought to be undermining public health. As we wait for science to issue the final verdict, researchers are facing a challenge.
Ce qui m'intrigue beaucoup à l'heure actuelle, c'est de comprendre le couplage entre l'onde et la matière vivante.
How they interfere with themselves, it's not known.
When radiation waves come in contact with living organisms, boundaries get blurred between two generally distinct fields, physics and biology.
L'énergie associée à l'onde est tellement faible, ça force l'imagination. On se dit, mais comment ce couplage survient? Comment peut-il être suffisant pour induire des réponses?
Is the radiation used in telecommunications really perceptible by human cells? How could it disrupt this finely tuned machine? What exactly is revealed in the studies which have alarmed the media? As society waits for an accurate evaluation of health risks, researchers each go about pursuing their own strategy of investigation, surrounded by waves. Mobile phones hit the market on a massive scale in the early 1990s without any prior research into their impact on health.
35 years ago, I wrote a paper and I said that I thought that electromagnetic fields affected the way the body works. And the lawyers and the scientists who worked for, at that time, the power companies and the microwave oven companies, I mean, they called me everything but decent. They didn't analyze the work, they didn't criticize the work, they delivered a long series of ad hominem attacks against me personally. That pissed me off. That made me angry.
In Shreveport, Louisiana, Andrew Marino has devoted his research career to proving the effects of electromagnetic waves on living matter, an objective he set for himself back when he was studying their therapeutic effects.
The initial work had to do with understanding how the body's natural electrical signals are used to regulate and control its growth. And I was in an orthopedics department in the late 60s and early 70s, and we were interested in using this information to help grow bone, particularly after a fracture or an injury. And as part of animal experimentation regarding safety, before we applied electrical energy to people, we began applying it to animals. And we began to see changes in animals that seemed ominous, seemed serious.
Over the past 40 years, Marino has published close to 150 articles on the biological effects of electromagnetic fields. These articles shed doubt on the reassuring statements issued by the industries exposing the public. Since the 60s, the increase in artificial radiation has led to several studies among groups of people who are highly exposed to it. Those who live near airports or high-tension lines, personnel in the telecommunications industry, and above all, the military. But studies underscoring the functional troubles or risks of illnesses linked to low-level waves are systematically criticized.
The common wisdom in the early 1970s, at that time the focus was on radars and microwave ovens and power lines because cell phones didn't exist. The common wisdom was that the energy that they produce is so weak that it can't affect the body. So the seminal question then became, is that common wisdom correct or incorrect?
From the fields produced by electrical appliances to Wi-Fi, our daily environment exposes us to all sorts of radiation. But the concerns of both the public and scientists were rekindled with the invention of the cell phone, a radiation-emitting object that we hold right up to our heads. The reason electromagnetic waves are so intriguing to researchers is because of the energy they transport through space. Because when we talk about electromagnetic waves, in concrete terms, we're talking about a flow of photons. In other words, of particles that carry energy. The higher the frequency of the wave, the more energy the photon has. And the more photons there are, the more powerful the radiation.
L'onde électromagnétique, elle se propage dans le vide. C'est à la fois ce qui est mystérieux et ce qui rend les choses complexes, parce que c'est invisible, inodore, et c'est, je pense, tout le mystère qu'il peut y avoir autour de ces ondes électromagnétiques.
We distinguish different kinds of electromagnetic waves by their frequencies. The radiation used for communications has a relatively low frequency, which means not much energy. Cell phone signals belong to the microwave family, between 900 and 2000 megahertz. As this is lower than the frequency of light, we assumed they were harmless. Since the radiation known to be aggressive to matter, such as X-rays or gamma rays, occurs at much higher frequencies.
L'énergie du photon électromagnétique ou du photon téléphone n'est pas suffisante pour casser des liaisons atomiques. C'est-à-dire que les fréquences auxquelles travaille la téléphonie mobile, les fréquences sont telles que l'énergie du photon associé au radiotéléphone, concept qu'on pourrait utiliser, est trop faible pour casser une liaison atomique.
Back when the first mobile phones were put on the market, the only known effects of microwaves were thermal. At high power, in other words, when a large quantity of photons is emitted, microwaves cause water molecules to vibrate and heat up matter. This is how microwave ovens work. Cell phones function at frequencies similar to ovens, in other words, with the same type of photons, but at a power that's 1,000 times weaker. The question researchers first asked was whether the energy transmitted by phones was enough to heat the brain.
Le téléphone émet une puissance. Une partie de cette puissance émise va servir à communiquer. Une autre partie va se propager dans le corps, dans la main et dans la tête.
Joe VR is a physicist employed by a cell phone operator. The purpose of his research is to measure the energy transferred from the phone to the brain, to guarantee there's no heating effect. By measuring electric fields in liquid, Joe VR infers the energy absorbed by the 10 most exposed grams of the brain. He determines a phone's SAR, its specific absorption rate.
Suivant les individus, cette puissance absorbée va être variable. Il fallait trouver une méthode qui nous donne non pas la valeur exacte pour le téléphone, mais une borne supérieure. Donc on a défini, au niveau international, on a défini un fantôme, des liquides et des positions de test qui garantissent que la mesure du DAS avec ce fantôme et dans ces conditions-là donne une valeur maximale.
The SAR listed in a phone's instruction booklet states the maximum energy absorbed by the user's brain. The legal SAR limit is set at 2 watts per kilogram of matter, which ensures mobile phone users that no significant amount of heat is generated. Contrary to what this hoax ad by a company marketing headsets suggests.
Si je regarde l'augmentation de température liée à l'apport énergétique des ondes électromagnétiques, on va avoir une augmentation de température qui est inférieure à 0,1 degré dans la peau.
If you can focus on heat generating mechanism, you know that your device doesn't produce heat generation in the human head. If it did, no one could ever measure it because we can't stick thermometers into the middle of the brain, so it's safe. That's why I think, speaking as a lawyer or advisor, I might say, fund all those studies you possibly can.
The legal norms for telephones, based on the SAR, are more and more disputable because they rest on the assumption that health problems can only arise from thermal effects. What Andrew Marino suggests, however, is that radiation could have other consequences besides generating heat, at levels below what the SAR allows us to measure.
It's like a carnival game where you put a pea under one of 3 walnut shells and you move the walnut shells around and you try to confuse people where the pea is. And it's exactly the same phenomenon. They get you to be looking at this shell, but the real problem is under that shell. This shell is SIR. That's the real problem.
Les seuls effets connus avérés sont aujourd'hui les effets thermiques, ce qui ne veut pas dire que la porte est close et qu'il n'y a pas de question.
Among these questions, researchers' essential concern is whether or not artificial waves can have an effect without generating a rise in temperature below the legal limits. Does matter react to radiation without any detectable transfer of energy that can be measured by physicists?
Dans ma recherche, je m'intéresse à l'impact des facteurs environnementaux sur la physiologie des plantes. Alors, le cas des plantes est particulièrement intéressant à considérer puisque ce sont déjà des êtres vivants qui sont spécialisés dans le captage de rayonnement électromagnétique, la lumière par exemple. Donc on trouvait intéressant de voir cette capacité à percevoir le rayonnement électromagnétique pouvait s'étendre à des fréquences différentes.
Alain Villon's experiment on tomato plants caused quite a stir. Along with physicists from the Lasmia lab in France, who designed a reverberation chamber that gave perfect control of radiation exposure, Alain Villon exposed tomato plants to frequencies equivalent to those emitted by mobile phones for 10 minutes. To avoid any thermal effects, he used a level of energy lower than the legal SAR limits. The experiment showed that the plants did in fact react to exposure. They were quick to produce the protein calmodulin, a typical response when plants are exposed to environmental stress.
Quand on voit arriver le résultat de l'expérience, et qu'on se dit mince, c'est quand même beau, ça répond, et je crois que c'est encore plus beau quand ça vous amène une surprise. Parce que je me rappelle qu'on s'attendait à avoir des variations, mais pas pour ces pointes cinétiques-là, et pas pour ces valeurs-là. Et quand on a vu l'expérience, que ça se répète, on passe un blindage autour des plantes, et pouf, on n'a plus de réponse.
The experiment was widely cited in international publications. The results established by Villon's team called into question a scientific dogma. Living organisms can indeed react to radiation without a measurable transfer of energy.
Je crois qu'il faut bien garder mesure de ce qu'on montre. C'est à la fois très important sur le plan qualitatif, puisqu'on montre que ces rayonnements sont perçus et que les êtres vivants peuvent y répondre, mais il faut se garder de faire un lien direct avec un effet délétère.
Despite Villon's reluctance to implicate himself in the debate on health risks, this fundamental experiment attracted a great deal of media attention and reawakened concern about the consequences of artificial radiation. Are humans as sensitive to electromagnetic waves as plants are?
Usually at night, I became ill and I felt like I couldn't breathe. And sometimes I had a panic, I had to sit up. And I started to feel that I had problems falling asleep because I was afraid that I would stop breathing. I'm rather isolated at home. I can't go anywhere. I can't visit friends and so on longer.
I have changed occupation because of my electro-hypersensitivity.
In Sweden, over the course of the 90s, more and more people claim to be affected by electromagnetic radiation. Like allergic reactions, the problems they described forced them to take shelter, to withdraw and physically cut themselves off from a world that had grown hostile. Known for his militant positions, Ole Johansson is one of the first researchers in the world to seriously consider these people's symptoms. After leading studies on the skin cells of people irritated by computer screens, he's become a historical figure in the debate on artificial radiation by fighting for social recognition of these symptoms and giving them a generic name: electro-hypersensitivity.
Every human being is electrosensitive. If I would take you and put your fingers into the socket, you would have a strong voltage shock, you know. So that's a typical electrosensitivity. And that's normal, of course. But these people with the electro-hyper or oversensitivity, they react maybe to fields that you and we do not react to. When you look on the incidence, there has been some very sharp increases. For instance, 1997, and then the digital techniques in mobile telecommunication was introduced here in Sweden. And for some reason, the number of such persons and their complaints, they again started to increase.
Electro-hypersensitivity is officially recognized in Sweden as a disability, and 2% of the population claims to be affected. But although the number of registered cases is increasing throughout the world, the phenomenon remains a medical enigma.
If I know or can figure out what happens in the body, then I can also hopefully try to do something about it. I think most of us reason that way.
The opponents, the people that didn't believe in this from the very beginning, they said that such persons, they were just postmenopausal women, they were imagining this, they had some psychosomatic reaction, etc., which could be the case, although when new groups were added, these counter-explanations died away, of course.
Electro-hypersensitivity raises a question that has yet to be clarified, and arouses the curiosity of scientists. Because until now, no lab study has clearly proven the link between exposure and the appearance of symptoms, adding more fodder to the feud between those who suspect EH sufferers are victims of collective paranoia and those who consider them harbingers of a health scandal. The studies led by Andrew Marino explore the human body's capacity to detect signals at a very weak frequency. For 20 minutes, Marino isolates his human guinea pigs from all environmental influences and then submits them to random stimulation of an extremely weak electromagnetic field.
The basic idea of the study is to prove conclusively that electromagnetic fields enter the human body and are detected by the body, probably in the head, and result in changes in human brain electrical activity.
Analysis of subjects' brain activity shows that they do indeed detect the signal, even at an unconscious level.
The nervous system detects sound, light, heat, touch, taste, electromagnetic fields. The same process. There's a specialized cell located someplace. It interacts with the electromagnetic field that comes into the body and generates a signal to the brain to tell the brain that there's an electromagnetic field in the subject's environment. The brain recognizes that there's no useful information. It therefore ignores the signal. But this process of detecting and ignoring taxes the adaptive ability of the body. In other words, you're weaker if this is going on all the time compared to your health if this wasn't going on all the time.
According to Marino, humans react to electromagnetic waves in the same way as they react to other environmental stimuli. But this original theory remains restricted by the lack of funding Marino has for his research. At this stage, despite the growing amount of evidence, human sensitivity isn't unanimously accepted by the scientific community. But behind the problem of the body's sensitivity to artificial waves, the question of their harmfulness re-emerges. Do they represent a major public health issue? Governments are launching vast research programs, and scientists are called upon to provide rapid and final answers. In the year 2000, the European Union decided to fund the Reflex project, proposed by the Verum Foundation in Germany. The aim was to observe whether mobile phone radiation had adverse effects on human cells. Franz Edelkofer was the research coordinator. His role was to combine the expertise of biologists and physicists from 12 labs in 7 different European countries to come up with a study he hoped would be irrefutable.
Im Reflex-Projekt versuchten wir herauszufinden, ob die Mobilfunkstrahlung in der Lage ist, biologische Wirkungen unterhalb der Grenzwerte auszulösen.
4 years later, Edelkofer presented his report, which he centered on the most alarming results.
Die wichtigsten Ergebnisse lassen sich zusammenfassen mit: hochfrequente elektromagnetische Felder sind in der Lage, die Gene zu schädigen. Dies haben wir nachgewiesen durch das Aufzeigen von DNA-Strangbrüchen, von Einzel- und Doppelstrangbrüchen. Doppelstrangbrüche können ebenfalls zu einem hohen Prozentsatz repariert werden, aber wohl nicht 100%ig.
In fact, in a living organism, there are specialized proteins that repair breaks in DNA strands. But the bigger the breaks, the higher the risk that something goes wrong in the repair, which can lead to chromosomal aberrations.
Die Zellen, die eine Genschädigung aufweisen, sterben in einem hohen Prozentsatz der Fälle ab. Gelegentlich kann es vorkommen, dass eine Zelle überlebt und die kann der Beginn eines malignen Prozesses sein.
But many researchers are skeptical about the capacity of microwaves to break DNA strands, even indirectly. Edelkofer's results are highly disputed, and despite his admonitions, he's received no reaction from the EU, even though they commissioned the study.
Ich will in Gottes Namen nicht beweisen, dass die Mobilfunkstrahlung gesundheitsschädlich ist. Das ist nicht mein Begehren. Ich will mit meinen Kollegen, die denken alle wie ich, fragen und aufzeigen, ist da was oder ist da nichts.
In 2008, Edelkofer asked the European Union for more funding to verify the results he'd already obtained and see whether the effects observed with in vitro cells can also be found in living beings.
Ich meine, dass diese Studie nicht gefördert wird. Warum, ist schwierig zu sagen. Wenn die Europäische Union eine bessere Studie gefunden hat, die dies auch kann, nicht, dann freue ich mich darüber. Glauben tue ich es nicht.
Meanwhile, all over the world, a multitude of guinea pigs are being submitted to the entire range of microwaves in search of the majority of known illnesses. Many experiments come up with unsettling results. Many come up empty-handed, but they all reach the same cautious conclusion. More studies are needed.
Une étude ne fait pas le beau temps ou le mauvais temps. Il faut vraiment un faisceau de preuves.
In Bordeaux, France, the IMS is renowned for replicating experiments that have found adverse effects and contradicting their results. These experiments, partially funded by cell phone operators, are led by biologist Isabelle Legroy and Bernard Verret, an expert in electromagnetic fields.
Dans notre laboratoire, pratiquement la moitié de nos projets sont des études de réplication de résultats établis par d'autres.
Pourquoi on insiste autant sur la réplication ? Parce que si on ne peut pas retrouver dans les mêmes conditions un effet dans un laboratoire différent, ça veut dire que c'est un effet sur lequel on ne peut pas discuter, enfin, qu'on ne peut pas prendre en compte pour l'évaluation du risque.
L'un des meilleurs exemples des résultats positifs qui ont été répliqués par nous et par d'autres sont ceux du groupe de Salford en Suède, qui avait montré donc une perméabilisation augmentée de la barrière hémato-encéphalique chez le rat soumis à des ondes. Et les résultats que nous sommes en train de publier, mais qui ont été rapportés en congrès, sont négatifs. On est incapable de répliquer les résultats de Salford.
In Lund, Sweden, in addition to his work as a neurologist, Leif Salford conducts research on rat brains, and in particular on their blood-brain barrier.
The blood-brain barrier is very special. It has tight junctions. As compared to all the other capillaries in the body, the brain has a very special type of wall, which is highly constricted and which just doesn't allow things to leak out.
The blood-brain barrier prevents substances in blood vessels from passing into brain tissue. After exposing animals to mobile phone radiation for 2 hours, Salford noticed that the blood-brain barrier became permeable in 1/3 of the rats exposed, which provoked a leak of albumin.
When we, in the late 90s, after having studied 15 or 1600 rats, and found that this was a solid finding, there is for sure a leakage of albumin, the rat's own albumin, out into the neurons.
These leaks could be causing migraines or, according to Salford, the destruction of neurons.
A neuronal damage also might be an explanation when you talk about how a tumor is produced in these special, both the malignant type and the benign type.
On se dit, bon là vraiment la barrière hémato-encéphalique, si c'est vrai, si c'est reproductible, il faut vraiment en tenir compte. On essaie de le reproduire, d'autres essaient de le reproduire, et on ne retrouve pas la même chose.
And yet, the impact of electromagnetic waves on the blood-brain barrier has indeed been confirmed by several teams throughout the world. Of the 15 or so studies published, the majority confirm this type of effect. How can we explain that studies on the same animals, seeking the same effects provoked by the same waves, wind up with opposite conclusions? The confusion that emerges from all these carefully run experiments reflects the massive stakes resting on this research. Under pressure, laboratories find themselves pitted against one another. Some, funded by operators, are faulted for being lenient, while others are accused of negligence in their protocol. The data keeps accumulating, but society is still waiting for a final verdict. What conclusion can we draw from the thousands of articles that have been published up till now? Interpretations of the same data differ from one researcher to another, and the scientific truth eludes us. An essential question emerges from all this confusion. At what point should the public be alerted?
If you have like 5,000 publications in peer-review-based scientific journals, and if that's not enough, when is it? Is it 5,001 or 5,002? Or when is it enough? And who is going to decide that?
La base de connaissances que l'on a maintenant, si les donneurs d'alerte se donnaient la peine de l'éplucher, de vraiment approfondir, pourraient constater qu'il n'y a pas lieu à des alertes majeures en ce moment.
There is a huge amount of experiments now showing that there is something. And I would say that the governments, the states, the authorities, they really have a very, very strong obligation to listen to this.
In 2007, Bio-Initiative, an independent report, captured international attention. It compiled the most disturbing results of 1,500 studies and extrapolated a multitude of adverse effects on humans. In particular, cognitive troubles, sleep disturbances, hormonal upsets that could lead to breast cancer, risks of neurodegenerative diseases, various tumors in the brain or salivary glands, cardiac rhythm abnormalities, disturbances of the immune system, or even a decrease in fertility. This highly alarming report was signed by a dozen researchers who decided, on their own initiative, to alert public authorities and the media to what they considered to be a major health risk.
Les médias se sont récemment fait l'écho des inquiétudes.
And I think it's not surprising that the public is confused and doesn't really know what to think.
Les bruits les plus divers circulent en effet.
Est-ce que vous pouvez vous exprimer sur le problème de la dangerosité?
Le risque avéré n'est pas prouvé aujourd'hui.
The delicate position of governments faced with an uncertain risk translates perfectly into a fashionable concept: the precautionary principle.
We really need to ensure that the precautionary approach is taken. We also need proper research centres to be set up to ensure that the real effects of this kind of non-ionising radiation are actually properly examined by independent assessors.
But above all, the precautionary principle reveals an irrefutable fact. Research on health risks is always a step behind technological innovations. Torn between the urgency of the situation and the necessary objectivity, fundamental research is trying to understand how cells react to electromagnetic waves. After studying how plants responded to mobile phone radiation, Alain Villon expanded his research to human cells.
On a choisi comme type cellulaire les cellules qui assurent l'interface avec l'environnement, toujours pour garder cette idée de cellules placées à l'interface.
To study the interaction between waves and living matter, Alain Villon decided to focus his research on skin cells. The first stage of the experiment consists in seeing whether exposed cells trigger an adaptation mechanism in response to radiation. Because our cells are constantly adapting to environmental constraints. This is why they produce proteins, which are the workers in the cell. For example, when the temperature around a cell is too high, a specific gene is activated to produce proteins which temper the cell. Villon is looking for clues to protein production in cells exposed to microwaves. Are human cells sensitive to the waves of mobile phones?
Alors, on vient d'avoir les premiers résultats. Donc, la réponse est oui. mais avec des caractéristiques qui sont quand même différentes de celles des plantes. En particulier, la réponse est plus lente à s'établir. On est à peu près un facteur 2 à 3 fois plus lent.
The cells react 1 hour after exposure. These results show that human cells are sensitive to radiation levels comparable to those found in our environment.
Le fait qu'on observe une réponse, pour moi, ça veut simplement dire que le rayonnement est perçu. Maintenant, il faut apprécier la diversité de ces réponses. Donc, c'est la raison pour laquelle on a engagé la construction d'une biopuce.
This discovery opens the door for new research into understanding the consequences of this sensitivity. By exposing a biochip on which each human gene has been isolated, Vion's team should be able to identify the entire range of reactions that human cells could have.
On va pouvoir déterminer quels sont les gènes qui sont réprimés et quels sont les gènes, au contraire, dont l'activité est augmentée par l'exposition. Cette information, elle peut être reprise par d'autres équipes dont le métier est de faire des risques sanitaires. Ils peuvent dire, tiens, oui, on n'avait pas pensé à regarder cette voie métabolique. Est-ce que, si on regarde cette voie métabolique, on peut tirer des conclusions, ou pas d'ailleurs,
In response to this work, other researchers are focusing on a very specific cellular mechanism and exploring the consequences. This is the case with a major experiment published in 2007 by Ronnie Seeger.
The first question was, can we detect a response by no thermal effect, very low energy radiation for short time? And the answer is yes. Then we asked ourselves the next question. What is the mechanism? How the cell sends this low energy radiation and transmit it into the cell? The DNA is actually the commander of the cell. It tells the other parts what to do and how to do them.
Ronnie Seeger is a biologist at the Weizmann Institute in Tel Aviv. His specialty is signal transmission inside cells.
There are a large number of different receptors.
The aim of his research is to understand how DNA is informed by what happens in the exterior environment in order to trigger the production of appropriate proteins.
There are several different communication lines. It's actually like telephone lines. They take the signal from the membrane and bring it to the nucleus, and then the DNA can start operating and tell the cell what to do.
Proteins are produced from DNA. To adapt to the environment, the cell has to tell the DNA which proteins it needs. This is the role of signaling pathways which transfer information from the cellular membrane, upon contact with the environment, to the core, where the DNA is found.
We decided to apply a very low energy radiation, much below the energy that is emitted by a normal cellular phone, and for a very short time, 5 minutes, 10 minutes, 15 minutes, and see if we can see any changes in the communication lines.
When Seeger subjected the cell to radiation, he discovered the systematic overactivation of one particular signaling pathway.
We identified this pathway, we call it cascade, because it's one activating the other,
The exceptional characteristic of this discovery can be explained by the complexity of this signaling pathway.
Funny name. This one, phosphate, it's one activating the other, by transcription factors. Okay, is that clear?
Seeger's discovery aroused attention beyond the scientific community because this particular signaling pathway is also involved in cell growth. The overactivation of this signal could therefore favor the proliferation of cells. It's one of the characteristic mechanisms of the cancer process.
There is a chance that the radiation that we found under some condition. Again, don't want to alarm everyone just for the low energy radiation, but there are chances that with high enough energy, this will be somehow support production of cancer. Not cause it by itself, but support it.
But beyond the mere health issue, the collective goal of all these scientists is to identify the initial interaction between waves and living matter, the transformation of the physical energy from phone radiation into a biological process.
Le monde vivant, on peut le définir finalement comme une entité séparée du monde extérieur par une membrane semi-perméable. On peut le réduire à ça, le vivant, finalement. On voit que le rôle primordial joué par cette membrane, elle est fascinante.
Everything boils down to the semi-permeable membrane, the interface between a world of disturbance and the highly regulated balance of the cell.
Where is the interface between the physical response, the radiation, and the biological response, namely the enzyme?
Somewhere in the cell membrane could be a protein capable of detecting waves. To identify it, Marino's team honed in on the case of the glass catfish. This fish is extremely sensitive to electromagnetic fields and can detect minute fluctuations in the Earth's magnetic field. By applying extremely weak electrical charges to the surface of this fish's specialized cells, Marino attempted to locate the first receptor.
On one surface of that cell, we can find the specialized protein that detects these very, very weak fields. We expect to find the same protein when we begin looking for it in the human cerebellum.
It's very important because if you identify it, then you'll be able to finally come with solution to some of the problems that may occur by radiation.
Seeger assumes it's the protein NADH. His theory is that the distribution of electrical charges of this protein could be modified by the very weak microwave fields and trigger a chain reaction. Despite all of these cutting-edge studies, we still don't have a coherent explanation. But each researcher is gathering evidence in their own field that little by little clarifies questions about the health consequences of mobile phones.
The cell studies, they can give us information about mechanisms for cancer. But epidemiology is said to be the most important part if you look into the risk for human health, because we have to do with we are doing with human beings and not with animals in laboratories or cell studies.
In Örebro, Sweden, Lennart Hardell regularly carries out research to identify the causes of cancer in his patients. Contrary to lab experiments, Hardell's approach consists in observing people in their natural environment. He conducts epidemiological studies.
Well, the idea came in early 1990s when I was in a national group in Sweden looking into the whole field of electromagnetic fields from electrical supplies and from power lines and so on, because we had the debate about the leukemia risk. So I was on that committee, and when we looked into the data in epidemiology, we saw that there could be an association between electronics industry and brain tumors. So we decided to do a specific study on that.
Hardell's idea sounds elementary, creating two groups of people, one afflicted with a targeted illness, in this case a brain tumor, and the other group, the control group, not afflicted. By comparing cell phone usage between the two groups, Hardell tried to determine if the cell phone is a risk factor. The main trouble with this kind of study is gathering accurate information. How often did these people use their phones over the past 10 years? Which ear did they generally put their phone up to? Hardell's study, carried out on 4,000 people, is the most commented on in the world because it was the first to point out an increased risk of different kinds of brain tumours linked to cell phones.
What we see is that there is an increased risk after cell phone use for 10 years for gliomas and also for acoustic neurinomas. We can see that the risk for acoustic neurinomas is even a bit earlier than for 10 years, but it's highest risk the longer time you use it. And the same risk is found for the cordless phones, as used mostly in homes or in offices. We must point out that the individual risk is very low because it's 1 in 10,000 persons or whatsoever who got the disease, and if it's doubled, it's 2 in that population. But the problem is, of course, that this is a worldwide exposure, so still if the risk is low, individually you will get many cases because everybody is exposed.
Hardell's study focused on the impact of telephones, because the effects of relay antennas are even more complicated to measure. The power of their radiation quickly diminishes with distance. Relay antennas expose us to a much weaker amount of energy than a cell phone pressed up against the ear, but they do so continually. And until now, no study has managed to clearly evaluate their influence on our health. This lack of knowledge leaves the public and media without any rational tools to explain the recurrence of disturbing incidents. Public opinion has been inflamed by abnormally high rates of cancer among children in schools where relay antennas exist. While official reports conclude it's a coincidence, pressure from parents and residents is forcing operators to dismantle their most controversial antennas. After 15 years of research, the sensitivity of human cells to radiation from mobile phones has been confirmed by numerous lab studies. But statistics concerning the health consequences remain uncertain. If the risk of serious illness, such as a brain tumor, appears low for an individual, it could very well be significant on the scale of 3 billion users. As for the chronic symptoms of electrosensitivity, they're being documented more and more often. But the real impact of electrosmog still fades into the multitude of fears inspired by our environment.
We live in a world where people will smoke cigarettes. Now, I can't think of anything more foolish than that. But you see, if you desire to smoke cigarettes, and you know that they're harmful, the evidence that they're harmful hasn't been hidden from you, but you choose to do it, that's your choice.
The broad use of lung cancer actually started during the Second World War, and the epidemiology came in 1950s. Then it took very long time for society, the governments, to react. The same is for asbestos, used since 100 years, and there were some early indications that this is hazardous.
The only thing that I insist on is that the people who would make money from having certain factors put into the environment allow the research to be done honestly and honestly communicated.
The implication of major industrial groups in the research into health risks logically stirs up concern and consequently triggers suspicion. Little by little, communication strategies have replaced the strict scientific debate, as if some people's exaggerations could compensate for what others are hiding.
chaque cellule de son organisme est le siège d'un courant de haute fréquence qui est fermé sur lui-même.
Mostly history will show who is right or who is wrong. And I was the first in the world to show that Agent Orange gave the cancer, and we were very much attacked at that time. And the story is repeated by now.
In the recurrent debate on health risks, we expect scientists to provide definitive answers. But in a realm of new research, where different fields overlap and where economic interests are at stake, the scientific discussion is partially blurred. The clarity of the debate rests on whether we can provide the means for genuinely independent research. Then everyone will be able to make an informed decision as to the risks they are willing to take in the name of freedom of choice and what they are willing to sacrifice in the name of safety.